Welcome to today's webinar as part of the GeoConX webinar series for Utilities and Telecommunications. Today's webinar is enabling real-time GIS monitoring and the IoT with ArcGIS. My name is Randy France, and I'm the Telecommunications Strategy Lead for Esri. Joining me today will be Eric Bishop, Account Executive in our Business Development Group, and Patrick Hulls, Technical Evangelist Telecommunications in our Patterns and Practices Group. Today's webinar is part of the 2018 GeoConX program. Our next webinar will be Constituent Engagement, Communicating and Collaborating with Citizens and External Communities of Interest on June 13th. From July 9th to the 13th, we will be holding our Esri User Conference at the San Diego Conference Center in California. On September 12th, we'll be starting our webinar series again with Field Mobility, looking at managing and enabling a mobile workforce to collect and access information in the field. Our final in the webinar series will be on analytics. On October 10th, we're talking about discovering, quantifying, and predicting trends and patterns to improve outcomes. We'll be closing out the GeoConX program on November 5th to the 8th with the Esri GeoConX conference in Dallas, Texas. Hopefully you'll be able to join us for all or any of these specific events that I just mentioned. Today, we're going to be covering what is the value of IoT in utilities and telecommunications. You hear a lot about the Internet of Things. You hear a lot about real-time monitoring. What's the value? Why are utilities and telecommunications doing this? We'll be looking at some specific use cases and some case studies on electric, gas, and telecom, sort of the best practices. What have companies already done? What value have they derived from doing this? What challenges were they trying to address? And then we'll be closing out the webinar by looking at setting up and enabling real-time GIS in your organization. What does it take to get things going? What do you need to look at? What do you need to consider? How should you set up real-time GIS in your organizations? Throughout our webinar series, we talk about the complete GIS platform. And there's 5 basic components there. We talk about system of engagement, we talk about system of record, system of insight, system for IoT, and system for developers. Specifically today, what we're going to be covering is we're going to be covering the system for IoT. We talk about how you can build the system to monitor what is going on in your network, what's happening with your customers. We'll talk about ways to track, manage, and monitor assets and resources in real time. So what's the IoT all about? The Internet of Things. Well, there's no doubt our world is becoming more connected, and rapid implementation of IoT will accelerate this process. By 2025, there are forecasts to be over 75 billion connected devices worldwide. These devices will act as sensors collecting information on their environment. Most of us already have leveraged the IoT when we check the weather forecast before a trip, so we know what to wear, or to look for traffic congestion as we select the best driving route to work. IoT even helps me each morning. I commute on a train, and I can go into an app and it tells me the actual time that the next train will be arriving at the station. So I can perfectly time my departure. This trend is so widespread that last week, Lennar Homes announced that Amazon Alexa will be built into all their new houses. Think of a home where control of lights, security, temperature, and energy are managed through a central system. This will make our lives simpler, safer, and more eco-friendly. Utilities and telecom companies have been collecting network and performance data for decades. GIS technology has accelerated the speed by which you can collect this data and transform it into actionable intelligence. Processes that previously took days or weeks to collect and analyze the data have been reduced to minutes or even seconds. In a recent study of 70% of enterprises identified improving customer experience as a top priority for IoT. Imagine a system that can identify faults before they impact your customers. Customer complaints would plummet, not to mention reduce calls to customer service. The other hot markets for utilities and telecoms are facility, asset, and fleet management. Other areas with significant potential to generate are new revenues. In fact, 53% of enterprises expect data from IoT solutions to generate new sources of revenue. The opportunities are virtually unlimited. What I'd like to do now is conduct an audience poll here. Get feedback from you on where in your organization are you using IoT? You can select more than one option here. So which of these real-time feeds is your organization monitoring today? Click all that apply here. Is it in network equipment? Perhaps you're monitoring the performance of the network. Is it vehicle and crew location or status? One that's becoming very popular is collecting social media. You don't have to deploy sensors. You can essentially do crowdsourcing with social media. Or as I mentioned earlier, third-party feeds such as weather and traffic, things we use every day. Is your organization monitoring that, using that? Or perhaps you're just getting started, not monitoring any IoT feeds. Well, it looks like the top winner is network equipment, about 55%. That's closely followed by vehicle and crew locations or status. That seems pretty typical. Interesting, third-party feeds are not too far behind. And then the two that I think are offer the most promise are social media, and then there's about a fifth of you out there that are not doing anything currently, but I think this is a real opportunity. So we'll go through, we'll talk about some of the ways that companies are using the IoT today. They're using GIS to collect the information. So Eric, why don't you show how some companies are using real-time GIS?
Thanks, Randy. I'm excited to present to the group today and discuss real-time monitoring in electric, gas, and telecommunications customers. We're going to have some general discussions, demonstrations, as well as referencing some of the implementations of ArcGIS to address real-time data. Let's get started. So first, let's discuss monitoring or IoT sensors in an electric utility. ArcGIS is unique in its ability to integrate these multiple inputs and visualize the results and or patterns or provide situational awareness for all utilities. AMI, or Automated Metering Infrastructure, also known as smart meters, track the consumption and provide real-time usage data back to the utility. This evolution of AMI has allowed customers to not have staff of meter readers in the field, and they can connect those reads automatically from their AMI system. These meters can also send a signal when they're out of service or about to be out of service to enhance outage management. The outage management product specifically predicts the potential source of the outage and senses the infrastructure affected as well as the number of customers affected. Now with AMI, you also have a return from that AMI system when it's energized again and the customer is restored. The sensor network can feed into GIS and be visualized and shared within the utility, or you can have an external facing web map that would actually have a web view of this information and the restoration and estimated time of restoration directly to the customers through a web app. Another topic is voltage monitoring. Voltage monitoring is accomplished with specific sensors on the network that are reporting back real-time voltage. We can then take that data and thematically map the voltage and share it with internal folks that need to see that as part of their job, or we can have the monitoring software sense changes in voltage and change the actual symbol of the circuit or feeder or device where that voltage reading is coming from to represent a higher or low voltage. This has to do in California with the regulatory requirement on voltage, consistent voltage to all customers. The last application we're going to talk about is galloping transmission lines. And this problem is associated with certain specific variables that exist that may indicate the potential for the problem to happen. The basic information needed to predict this problem is wind speed, wind direction, temperature, and then rain or ice on the transmission infrastructure. The monitoring software would integrate wind speed, direction, temperature, and rainfall, typically from a third-party weather service, overlay that with the transmission infrastructure in the GIS, and focus attention on areas in the utility where they've experienced this problem in the past, or the conditions exist that offer a high likelihood of this problem happening. The crews could be dispatched to the area, or mitigation measures could be considered or budgeted to dampen the problem on specific transmission lines. Now let's transition to Patrick. He's going to show a demonstration of a sample application for an electric utility. Patrick?
Thank you, Eric. So in this electric example, let's take a look at some real-time weather and two examples of how weather can impact our transmission network. So within our GIS system for IoT, we're pulling in real-time radar, lightning strikes, wind, rain, temperature, and other general weather warnings. And this bluish heat map that we can see here on our map indicates a high density or volume of lightning strikes. And if we zoom in closer to this heat map, we'll start to see the individual lightning strikes and where they are on the map and in relation to our distribution network, or within in relation to our transmission network. Now, using real-time GIS, we are able to buffer all of our substations by 20 miles and get notifications when any of these lightning strikes intersect within 20 miles of our substation. So here we can see in our list the total number of lightning strikes that are within that 20-mile radius of our substation. So real-time GIS not only allows us to monitor real-time asset information, but allows us to incorporate other sensor feeds like weather so we can forecast possible disruptions within our network. And the second example of how weather can impact our network is through a phenomenon called galloping transmission lines. And Eric mentioned this, but galloping transmission lines occur when rain freezes on transmission lines and the wind is strong enough to cause the lines to spin or gallop. And then these lines can hit each other, causing a short circuit. So within our galloping warning list, we have a listing here of where rain, temperature, and wind exceeds a predefined threshold and then intersects with a specific segment of our transmission line. So if we zoom into the map, we can see all of these segments of the transmission line where these conditions are true. This will allow us to reduce the voltage within the line or send crews out to this particular area. So now I'll turn it back over to Eric to talk about a particular case study from SDG&E.
So SDG&E is San Diego Gas and Electric, San Diego, California. Their customer challenge was they have a lot of distributed energy, specifically solar and wind, which is causing their distribution network to behave a little differently than it was designed for. So the proliferation of renewable energy, they're trying to sense and react to what's happening when there's full output from a solar or it's covered with clouds due to the coastal influence, and they're trying to monitor that constantly. So they do have regulatory pressures along with this. They have to maintain a consistent voltage as part of a regulatory requirement. The Esri solution they're using is a real-time GIS system to monitor and visualize the voltage within their networks. The lower panel is kind of showing a thematic map of voltage, real-time from the sensors in the network, and then the panels below the map are actually a historical view, so you could look at the voltage right now. You could also play that back for the last 5 minutes, the last 24 hours. So they can query and analyze and display this historic voltage data at the locations they've picked. Part of the customer results they've got out of implementing this system is maintaining voltage stability and the two-way flow within their distribution network. And also another benefit is their ability to stabilize and maintain this mandated voltage across their entire service territory. So let's now discuss monitoring within a gas utility. AVL, or automated vehicle locations, are being tracked and managed through ArcGIS and would allow a gas company to dispatch the nearest, or specifically the crew that could get to the problem location the fastest. This would take into account traffic, speed limits, crew specialties needed to complete the leak investigation or the emergency work at that location. The benefit of having this monitoring is the quicker identification and response to the event and reporting of the field location and information back to the office, so crews have the ability through dispatch as well as their work management system to manage the event more effectively. Real-time monitoring or pressure in the network is also something that can be implemented within some gas utilities. So now let's have Patrick show an example for a gas scenario.
Thank you, Eric. All right, so in the second example, let's take a look at a gas network and some monitoring of automatic vehicle locations, or AVL, and how we can optimize response to a reported gas leak. So within our map view, we have our existing gas network, as well as a density heat map of all the historical gas leaks that have been reported. We also have the real-time locations of our field technicians out in the field, as well as their current status. So if we click on one of our field techs, we can see the vehicle type, their current speed, and their status. Now, through this AVL tracking, we are also able to have the vehicle report not only their current location, but also their past 10 known locations. So we can follow this truck along the map. Now, it looks like that we currently have one active Class 1 gas leak, or a high priority gas leak. So let's run a report to get some additional information on this particular leak. Running a report shows us exactly where this gas leak has been reported and allows us to pull up additional information on this particular leak. Now, using those real-time AVL feeds, what we want to do is figure out which of our field technicians can respond to this particular gas leak the quickest. Using spatial analysis, we can optimize which field technician can respond to this particular gas leak by looking at which tech is currently available and has the right skill set to respond to this particular Class 1 high priority gas leak. And for this analysis, we want to base it off of driving time to look at the shortest distance and time that it would take to respond, and even incorporate live traffic into this analysis. Now, the results of this particular spatial analysis return to us which field technician is the can reply or can respond to this gas leak the fastest. So if we select on the route here, we'll see the nearest field technician, how far they are away from this gas leak, and how long it's anticipated that it will take them to respond to this leak. So by monitoring and analyzing our real-time AVL feeds with the GIS system for IoT, we can optimize our field work and respond to incidents faster. And now I'll turn it back over to Eric to go through a second case study from PECO.
Yeah, PECO is part of Exelon, the company. I think it's Pennsylvania Electric Company. So their customer challenge was odor calls and responding to this odor call within a 60-minute regulatory imposed time window. So when the odor call came in, the stopwatch started for that 60-minute time to respond. The solution they implemented was real-time GIS and the AVL tracking of location of all of their vehicles and their in-service status. Now, within the AVL, they did not really have a fully vetted system that showed you integrated to HR when people were on or off the clock. So one of the variables they took in out of their AVL was if that truck had been idle for more than 5 minutes, or if the key position in the truck was switched to off, those trucks were not evaluated in the response to the specific odor call or solution. They also had a dashboard app for managing the gas leak reporting, so all the leaks calls that have come in, as well as managing their fleet of technicians and where they were in the service territory. They used this to actually solve the problem and dispatch the right vehicle with the right specialties to get to that odor call within the regulatory time window and try to meet or be below that 60-minute regulatory imposed time window. They also, when they got to the site, were using their GIS network management system or system of record to actually look at the network and trace out from where they were to find the isolation valve to isolate, if they had to, that specific segment of the GIS network. So their customer results were to shorten the gas order response time and meet the regulatory time window, as well as faster locates of the gas valves and isolation to manage the leak. So now let's talk about real-time monitoring within telecommunications. The outside facilities monitoring and visualization of outages in a telecommunication network can be monitored in ArcGIS. An example of an outage may be a cut or a bad splice in a fiber network that causes loss of service along that segment or to a certain amount of customers. Another view could be of the network operations center. They name those a NOC, and the variables and the health of that network operations center at any time when interrogated by a user. This real-time data can be viewed and analyzed for the location and or multiple locations that were selected. Another way to think about this in telecommunications on the wireless side is a call record and user movement in the network. I'm going to take this at a very high level, and Patrick will break this down a little further in his demo. An example could be tracking the usage and movement of a customer during rush hour along an interstate highway. The density of users, the call volume, and the bandwidth being consumed are all being impacted along this corridor. The telecommunications company needs to plan or react to have these variables consistent, so they have consistent service, no calls are dropped, as well as enough available bandwidth along that segment of the interstate where it's congested. The telecommunication company also wants to monetize their customer information and location so they can offer more reliable service and potentially offer additional offers to segments of their customers that could benefit from adopting a new program. Let's have Patrick show a demonstration of what this might look like within telecommunications.
All right, so for this third and final example, we're going to take a look at a telecommunications network and monitoring a variety of real-time feeds. So the first feed that we're pulling into this GIS system for IoT is current network connections or device connections to our wireless network. We can also see the total volume of data that is being consumed by our customers. And we have a breakdown of which of our site sectors are the top 10 and lowest 10 performing based off of that data consumption volume. Now within our map view, we have our wireless network, and if we zoom in closer here, we will start to see the individual cell sites as well as the sectors that have been symbolized based off of that total call volume or in this case, total data that is coming across that particular sector. Now, a second fee that we are pulling into the GIS system for IoT is current network alarms or network faults. So on the left-hand side of this dashboard, we currently have 6 alarms that have been triggered with a listing of those alarms. And we can see kind of the clustering of those alarms here on our map. Now, because we are using GIS, we have mapped out our coverage areas for each of our cell sites, and we can visualize the impacted area by these offline cell sites. Now, because this is a wireless network, we do have overlapping coverage, and we can turn on the coverage areas for all the other cell sites that are still operational and highlight the exact coverage holes within our network. So the next step would be to prioritize which of these sites to send a technician to get back and operational. And we can base this prioritization off of impacted or possible impacted customers. Now, using this real-time GIS and the system for IoT, we can understand who were the last connections to any of our sites and sectors, as well as the projected mobile and business and SLA customers that could be impacted by this particular coverage. And looking at the map, it would seem that this particular coverage hole is the largest within our network. But if we select on this particular site and its offline coverage, we see the number of possible affected customers jump up. And if we select on the smaller of the coverage holes, these numbers drastically increase. So using real-time network data and spatial analysis, we can better understand how many potential customers are impacted by these outages. And this can help us prioritize response and ultimately improve the overall customer experience. And now back to Eric to talk about one more case study from Mid-Atlantic Broadband.
Thanks, Patrick. At Mid-Atlantic Broadband, their customer challenge was reporting and restoring network outages faster. So when there was a network outage, they didn't originally have a way to communicate to that customers. The result was a high call volume of customers inquiring to why their service was out, and they had no way of knowing when that service was going to be restored. So in the Esri solution, they basically developed a GIS-based network management system with field apps as well as a public map outage viewer. So the idea here is the field technician that was on site had a copy of the network data. When they were doing restoration on site, they could report back to the office that their estimated restoration time could be 5 minutes, could be 10 minutes. But when they had that part of the telecommunications back in operation, they would say, at this point, we have restored, trace all the customers along that network, and then automatically send it back to the home office, which would cause the customer-facing website to actually update. So now the customers had a real-time view of when they should be restored, and they also had a customer-facing map to show the status of the network and current restoration times. Some of the customer results are fewer people required to restore the network, as well as fewer people in the call center to take the number of calls that was coming into Mid-Atlantic Broadband. By implementing this solution with monitoring as well as GIS, they had the ability for faster updates of outage status, as well as time to restoration for their customers. So how can you set up and enable real-time GIS? I'm going to transition back to Patrick, and he's going to show a little bit more about the technology from Esri that is used for real-time monitoring and IoT integration.
Great. So for this next part of the webinar, we'd like to take some time and talk through how to actually set up and enable real-time GIS. You know, we've seen a lot of great examples so far and case studies, but how do you actually deploy a GIS system for IoT within your organization? Well, real-time GIS can be enabled utilizing the ArcGIS platform. And ArcGIS can be deployed as an off-the-shelf, ready-to-go IoT platform, or ArcGIS can complement an existing IoT platform and provide additional mapping and location capabilities. So the real-time capabilities of ArcGIS are enabled through an ArcGIS enterprise server role called GeoEvent server. And the way that GeoEvent server operates is by ingesting real-time feeds through a web protocol into GeoEvent server, in which streaming analytics and business rules can be applied to those data feeds. Then that data can be, something can be done with that data. It can either be stored in a ArcGIS big data store called spatiotemporal for historical queries and playback over time, or this information then can be visualized in kind of one of two ways. One way is through a stream service. So this is if you've got high volume of fast moving data. So that AVL feed was using a stream service, which is just pushing the locations to the browser's cache and not actually doing a query to the back-end database. So this allows for that very quick visualization of fast-moving features. Or these features can be visualized and queried from the database using traditional map and feature services. Either way, these visualization services can be accessed through a variety of configurable ArcGIS-based web, mobile, and desktop applications. And within GeoEvent server, there are kind of three main components. And the first component is the input connectors that allow for that ingestion of real-time data. And there are dozens of these out-of-the-box input connectors that tap into those sensor feeds and ingest that information from a variety of different web service protocols like XML, JSON, or RSS. There are also connectors to a variety of open source libraries and IoT platforms like Kafka, as well as out-of-the-box social media connectors to Twitter and Instagram. And then there's also connectors to third-party IoT platforms and partner solutions like Amazon and Azure IoT, as well as Verizon Network Fleet for that AVL tracking, and OSI Soft. The second component of GeoEvent server are the GeoEvent processors. Now, these are the processors that apply business rules and continuous analysis to that input data streams. And these processors can be very simple attributes or spatial filters in queries. So if data is coming in and you want to look for either a particular location or a particular attribute, and then either store that information or do something with it, these processors are where you can apply those business rules. You can also apply a field calculation or enrich fields with geographic information as that data is flowing through GeoEvent server. And you can even do geocoding kind of on the fly, either XY geocoding or reverse geocoding from an address as those data feeds are coming into GeoEvent. And now the final component of GeoEvent server are the output connectors. And these are the connectors that then do something with that data as it has flowed through GeoEvent server. And these connectors can push features into a traditional feature or stream service, which I mentioned, into ArcGIS. They can also push features back into a web service protocol format like JSON or TCP, so you can automate and trigger something within your devices and within your network. And you can even send notifications to people or field technicians through emails or text messages. And there's also a variety of connectors for third-party big data stores like Hadoop and MongoDB. So if you want to store the historical data within ArcGIS, you can do that, or if you want to store that historical data into a third-party big data store, that option is also available. So now GeoEvent Server and this Real Time GIS product and capability is nothing new to Esri. And we've been continually improving the performance over the years. So at the latest 10.6 version of ArcGIS, GeoEvent can now handle up to 6,000 events per second of throughput. And GeoEvent also allows for resiliency and failover of by deploying multiple machines. You can also deploy and scale out multiple GeoEvent machines, which means that you can scale up to actually 30,000 events per second. And GeoEvent can easily integrate into other Internet of Things or IoT platforms like Amazon, Azure, like Amazon and Azure, so that you can kind of offer additional mapping and spatial analysis and location capabilities to your existing IoT platforms. And all of the input connectors and processors and output connectors that I mentioned before have software development kits or SDKs available, which allow for developers to customize or even create their own connectors and processors that really improve the interoperability of GeoEvent Server. Now let's talk a little bit about how to get started with GeoEvent Server. So there's a few very kind of simple steps. First, you set up your input connectors, so which feeds and the types of protocols that you need to tap into to pull in those feeds into GeoEvent. Then you set up your output connector. So what do you want to do with that data? Either push it into an ArcGIS service, send out a notification, or push it into a third-party data store. And then you set up your GeoEvent processors. So what type of streaming analytics or what type of other business logic you want to apply to that data as it's coming in. So if you're pulling in those 30,000 events per second, there may be times where you only want to do something with 100 of those events. And so these processors are where you can apply those business rules. Once you've got your input, your output, and your processor set up, that is then turned into a service and is live, pulling in that information and then doing something with it. Now, I know that was very high level, but if you want more information on how to set up GeoEvent Server or extend this particular product and develop on top of any of these connectors, there's actually a webinar, part of the GeoDev webinar series that is tomorrow at 9 a.m. Pacific Daylight Time. And this link here will get you access to registration for that webinar. There's also a GitHub site that has a lot of great information on integrating ArcGIS into existing IoT platforms, as well as a complete listing of all of those connectors and processors. You can also turn to GeoNet and the GeoConX community and ask any questions and engage there. We'll be posting a lot more blogs on how to set this stuff up over the coming weeks. And you can also reach out to your account representative or email us at geoconxinfo@esri.com for any additional information. So now what I'd like to do is turn it back over to Eric to discuss a little bit more on what to do next.
Yeah, from a business perspective, thanks, Patrick. From a business perspective, take an inventory of your organization's real-time data. We referenced, the poll that everybody responded to, what they were doing with real-time data earlier in the webcast. Consider those sources. We've showed you today weather integration from a third-party feed. We've showed you an example with San Diego Gas and Electric of real-time sensors of voltage feeding back into the network, and understand where your feeds are within your organization and orchestrate those. From a business need, with those real-time capabilities and the organization's strategic goals, where can you add value, or what kind of problem can you solve by having those real-time feeds connected to your GIS system, and then correlate all that geospatial data and where you can add value to your system with analysis, impacts, as well as assessment or spatial groupings of events that are happening in the location. This can be for spatial as well as non-spatial data within your system. And then get started with ArcGIS Enterprise as well as the GeoEvent server extension. So I'm going to turn it back to Randy, and let's move to questions and answers and a wrap up for this webinar today. Randy?
Thank you, Eric and Patrick. Quite exciting stuff that you've shown everybody here, and what's possible and what people are doing. I want to let everybody know that we have got a lot of questions in here, but there's still time to submit your question. We can't get to all of them. We will be putting out a Q&A afterwards and delivering that or sending it out to all the people that have attended here. First one we have here is, how are you pulling in weather?
Yeah, so I'll take that one. That's a great question. So the weather that we showed in a couple of the examples is coming from a variety of different sources. So Esri provides real-time weather feeds and kind of weather warnings out of the box, a part of the ArcGIS platform. Those weather feeds can be incorporated into your geofencing and buffer analysis and intersection like we showed in the electric example, as well as used as a visualization layer on top of your maps. There's also a variety of partners that provide real-time weather feeds that you can subscribe to and incorporate those into the ArcGIS platform and use those as your feeds for analysis and visualization as well. So there's a variety of different options, as well as I'll mention a third, if you have a weather feed coming from a third party that isn't a Esri partner, you can also incorporate that into GeoEvent server and pull it in as just another input feed to do some analysis and visualization with.
Okay, great. Here's one. What is considered real time? Can I use for safety critical information?
I would say yes. I'm not really understanding what the safety critical information is they're talking about. The example we showed, I mean, just to reflect on one of the demos, was the ability within the PICO case study of taking an AVL feed, looking at whether that truck was in service or out of service, and actually dispatching the truck with the right specialties or the right requirements to do the job, and trying to figure out the fastest way to get them to that work order within the regulatory time windows. So if I'm understanding the question right, Randy, that would be my response, or how I'd answer it, with not a very great level of detail.
Okay, great. In the SDG&E case study, are they linking to the SCADA, to the GIS, and how hard would it be to do that?
Sure. I'll take that. This is Eric. SDG&E is using one of the connectors, or the input connectors. They are managing their sensor data and storing all that temporal data within the OSI Pi framework. And then they're using the GeoEvent connector to OSI Pi to receive that voltage or look at a threshold, or is that voltage above or below a threshold, and then they are changing the thematic map of that facility or that sensor to match that threshold. So it will change, you know, from green to yellow if there's a warning of its approaching voltage that they cannot have or is out of the regulatory requirement, but they're using specifically the OSI Pi connector and orchestrating that through GeoEvent tied back to their system of record or their infrastructure management on distribution as well as transmission.
Yeah, and to add to that, I think that's a common deployment pattern where there's existing feeds coming into existing systems or different IoT platforms in which a connector of GeoEvent can also tap into that feed. So as you've got the feed coming into an existing system, you can also push that same feed into ArcGIS and allow you to do the visualization, some spatial analysis, and then even push an output of that back into either that existing system or send notifications to the end devices. So I think GeoEvent Server is very malleable in that sense that it can be deployed kind of anywhere along the workflow or that stream of data to add additional value to your IoT.
Good. Is there a custom application built on top of the GIS for the gas and electric monitoring?
So I can take that. The example that we showed was not a custom application. That was a configuration of Web Application Builder, which is a web-based application that allows for easy and fast configuration of web apps with a variety of different features and capabilities that can be added to that application. Now, along with the majority of our products, there's a software development kit which could allow your developers to develop a customized application on top of ArcGIS that incorporates those real-time feeds. But what we have seen is that the business value comes when organizations can stand up these applications a lot faster and configure first and kind of develop or customize second.
Good. This came in during the gas leak discussion and demo. What are the tech stacks that are part of these enterprise solutions that are being showcased?
Yeah, so in detail, we don't have a high level of detail time to go in that. We could connect the user with that customer to discuss that in detail, but they actually have an AVL feed through a third party. So the AVL was coming in. They did not, when I mentioned the key position or the idle time vehicle, so they did not have a connection back to their human resource application to know if that person was scheduled to be at lunch or scheduled to be not working that day or on vacation. So as a proxy, they were just taking the AVL and saying, hey, has that truck been idle for more than 5 minutes? Or is the key position in that truck through the AVL switched to off so it potentially is out of service? You know, so they were using explicitly the GIS information, data coming in from the call, odor call website, as well as their AVL to enhance their solution and dispatch people within that time window. So integration to their HR had not been accomplished yet and wasn't a feed that they could get real time. So they were basing it off the calls, the GIS, as well as their AVL feed.
I think this relates to the general demos and what was shown here. What visualization software was being used? Was that an Esri product?
Yeah. So all the visualization layers and maps are a part of ArcGIS. I mentioned a couple of the different visualization techniques that are part of ArcGIS. So, you could think of it as kind of two levels. One, there is the interface side that is a kind of JavaScript-based application that has been developed to allow for quick rendering and visualization of information client side. But there's also a stream service that you can publish out that isn't dynamically querying a backend database. It's just pushing the feed to that service, so you can render that information very quickly and kind of see the things moving across the screen very rapidly. There's also another visualization technique that we didn't show that will allow for kind of aggregations of lots and lots of amounts of data. And so it's called binning or spatial aggregation, and you can basically lay out a grid, either a kind of hexagon shaped grid or a square grid, and then aggregate all of those features into each bin size, so you get kind of a dynamic heat map that shows you the aggregated total number of features or aggregations of a specific attribute. So if you want to sum the value of an attribute within that region, you could do that. So there are a variety of ways, depending on what you want to visualize within that end information product, that is all kind of a part of ArcGIS.
Okay. Do users buy GeoEvent server separately, or is it part of a package offering?
GeoEvent server is a separate offering that connects into ArcGIS server or ArcGIS Enterprise.
Okay. Is there any sort of historization or storage integrated into the GeoEvent server?
Yeah, yep. So back on my kind of conceptual architecture there was a spatio-temporal data store, as we call it, and that is a big data store with kind of a geodatabase format sitting on top of it. So that information can be stored into that data store and allow for kind of querying of that historical information and rendering of it, as well as kind of the playback over time through those visualization layers. So I did mention there's also a variety of third-party big data stores that we can integrate into and provide similar capabilities.
Okay. How do you combine information from different feeds to provide alerts? And they're specifically talking about the way you combine wind speed, temperature, rain, etc. in your demo.
Yep. So each of those feeds would be a separate input connector. So you'd have a rain connector, a wind connector, and a temperature connector. Those feeds would come into GeoEvent server, and then within those GeoEvent processors, you would set up specific queries to say if wind is greater than X or between X and Y, then do something with that. So similar processors would be set for each of your kind of input variables. And then you would look for areas where all of those queries meet a certain condition, and then based off of that, then do something with it. So that's when you would either send an alert to a map service so you can visualize somewhere in our network where those have occurred, or maybe you want to send an email notification to somebody to let them know the exact wind speed, rain, temperature, location, and then maybe an asset ID of where all those intersect. So you can configure all of that within the kind of body of GeoEvent.
Very good. Can you talk more about the reporting widget and web app builder dashboard app?
Sure. So the reporting widget allows you to query features within your map or your map service. So you can kind of configure or customize that widget to pull back a variety of information from whatever type of map or feature service that you have behind the scenes. But it's very malleable and it will report on essentially however you want to set it up. Attribution, you want to get aggregated totals of something, summarize information, so that can be all done through that widget. And if you want more information, feel free to reach out to us and email us, or check the GeoNet community, because there's a lot of great information there on how to set up a lot of these applications and widgets that are part of the apps.
Okay. Is GeoEvent server and spatial temporal big data store available on ArcGIS Online?
It's a good question. Today they are not. So GeoEvent server and the big data store are only available through ArcGIS Enterprise.
Okay. I think we have time for one more question here. We'll run up at the top of the hour. How many assets are you able to track in real time, and at what update frequency? I think you talked a little bit about the frequency, but how about, is there a limit on the assets?
Yeah, so I mean, with real time, it really varies depending on you know, the volume of data and the frequency of data. So you know, GeoEvent can scale out to handle 30,000 events per second. So depending on, again, kind of the frequency of the data coming from the assets, if it's every millisecond, if it's every second, every 5 minutes, it'll just depend on what you're trying to do, the business case you have, and what you're trying to get out of it. So that would be a great question to reach out to us directly, so we can kind of talk through the business process and workflow that you have today and what you're trying to do with that data as it has come into ArcGIS.
All right, thank you, Patrick and Eric. We're up against the top of the hour here. Want to be cognizant and appreciate everybody's time and effort here. We weren't able to answer all the questions. We still have a lot more questions, but we will be putting out sending out the answers to the questions we didn't get to, plus the ones we already did, getting that out to everybody who attended. And as I said earlier, the video, we will be creating a video, will be available next week. On your screen here, you can see other groups and ways to interact with Esri and ArcGIS users. That can be through the user groups. We have a TELUG and an EGUG. We also have community discussions for both Utilities and Telecom with GeoNet, and through our Twitter feed. You can contact directly the Esri Telecom team or the Electric and Gas team. So those are ways to get in contact with us. If you need more information, feel free to give us a call. And with that, we'd like to thank everyone for joining us today, and hope you have a great week. And if you need the video, we'll be sending out that link, and we'll be sending out answers to those questions which we were not able to address. Have a great day.